On January 3rd, 4159, the sun will not rise anywhere on the planet. It sounds like complete nonsense, but it is impossible to refute this statement without reaching the corresponding date. Throughout our lives, every morning the sun rises in the east, and every night sets in the west. And judging by numerous historical sources, the sun has behaved this way for thousands of years. So what are we doing? We conclude that this will always be the case. That is, from a certain number of observations, we will have a general rule. But do we have a reason for this? How reliable is this rule? This is the so-called problem of induction. Mathematician and logician Bertrand Russell, in his work on problems of philosophy, writes about a chicken to which its owner poured millet every day since birth. The chicken grew fat, and drew conclusions. He extended or extrapolated the results of his daily observations into a theory about the good master. And every time the chicken was fed, his theory received more and more evidence. But one fine day the owner came with an axe and cut off the chicken's head, thereby immediately disproving his inductive theory. Again, it is inductive insofar as the chicken made a general conclusion based on a number of observations. You will say that the chicken theory was superficial. He did not have the whole picture. He simply did not have access to the understanding of what people call animal husbandry. And so, the chicken simply had a false idea of cause and effect. But why do we suddenly think that people have this idea as true? Causes, effects, does the second always follow the first? Do we always see the whole picture ourselves, and does such a picture even exist? When you turned on this video, you were probably tormented by vague doubts. What? Will there be tomorrow? How can tomorrow never come? Are we facing some kind of catastrophe? A meteorite strike or a supernova explosion nearby? Well, as far as I know, there is nothing like that. And yet the fears are completely justified, because I'm talking about more global things than a pathetic pile of space rock or even the explosion of a giant star. The reason tomorrow suddenly doesn't come may well have to do with how the universe probably came into being. We are so convinced of the correctness of personal experience that immediately after the publication of the special theory of relativity, cries began to be heard from everywhere that the theory was producing a bunch of paradoxes, and in support of their words, heralds offered various thought experiments. The special theory of relativity tells us that for a stationary observer, the length of moving objects is reduced in the direction in which they travel. Imagine a 10-meter pole and a 5-meter shed based on the provisions of the special theory of relativity. If the pole moves fast enough, no, in fact, the speed should be close to the speed of light. At this speed, the length of the pole will be reduced so much that the pole, flying through the barn, can fit entirely into it. But the theory of relativity is named so not because it sounds nice, because from the point of view of the pole, it is the pole that is motionless. It is the barn that is moving towards him at breakneck speed, and it is the barn that must shrink in size. Thus the pole will not be able to fit into it. This is the essence of the paradox, because the pole can fit and not fit in the barn at the same time, right? People offer their own in quotes, refuting thought experiments that took into account some effects, the special theory of relativity, but did not take others into account. Meanwhile, Einstein's theory is mathematically consistent. Yes, in the example with the pole and the barn, there is actually no paradox. Everything will be exactly the same from the point of view of the barn. The pole will fit completely into it, but at the same time, from the point of view of the pole, the barn seems too small for this. And the point here is the relativity of simultaneity. Simultaneous events for one observer in his frame of reference may not be simultaneous for another observer in another frame of reference. And the question of whether the sixth one is in the barn must be considered by each observer of both the sixth and the barn separately. If we are in the frame of reference of the barn, then there is a moment when both ends of the pole will simultaneously be inside the barn. If we are in the reference frame of the pole, then the moment when both ends of the pole will simultaneously be inside the barn does not exist. You may ask, but whose point of view would be correct in this case? The answer is both. Yes, objectively simultaneous events in one frame of reference will not objectively be simultaneous in another. Sounds like cruel nonsense. But in general, this is a scientific fact verified by experiments. And these experiments were by no means mental. Moreover, for different reference systems, events can even occur not only non-simultaneously, but even in different sequences. Doesn't this undermine our understanding of the concept of cause of effect? Well, actually no, but can you definitively say with complete certainty that there is a connection? For example, between the time I let go of the pencil and the time it falls to the ground. The construction of cause and effect relationships is a very deep property of the psyche of living beings, and not necessarily the objective world. Frederick Skinner conducted a number of interesting experiments. He made special individual cages for pigeons. Each cage had a button located in such a way that the probability of accidentally pressing it was small, but if pressed, the pigeons would receive some food into the cage. After several random presses and food rewards, the pigeons quickly understood what was happening and built a cause and effect relationship between pressing the button and receiving food. But the most interesting part of the experiment began when the Skinner set up the devices in such a way that the food was dispensed randomly. That is, all the pigeons had to do was sit and wait. Food entered the cage itself at certain time intervals, regardless of the actions of the pigeons. However, such chaos did not suit the birds at all. They began to associate the distribution of food with things that had absolutely nothing to do with it. For example, if a pigeon stood with its neck stretched out to one of the upper corners of the chamber at the moment of dispensing food, then from his point of view, this was precisely the reason for feeding, and in the future, he repeated the cherished movement over and over again and became increasingly convinced that it worked after each subsequent promotion. Pigeons developed entire pronounced rituals. Some birds made swinging movements and alternating motions, as if sticking their heads under an invisible barrier and lifting them up. Someone performed pendulum-like movements of the head and body. Someone made a pecking movement towards the floor, but without touching it, and so on. The mechanism for constructing cause and effect relationships is a very useful mechanism. It promotes survival and is inherent in all highly organized beings. But isn't it the same mechanism that forces us to see the point in talismans or in not calling the 13th floor the 13th? After all, what is the connection between a bauble around your neck and success in life, or in numbers and failure? The same mechanism makes us believe that if a pencil falls down 1,000 times, it will go to 1,000. But will it fall? The English philosopher David Hume did a good job of demonstrating that the very concept of cause and effect relationships is abstract and exists only in our heads. Example: now we have the objective world around us, and there is the area of the human psyche, our inner world in the objective world outside of us. Perhaps there are some objects, for example, bricks, broken glass. In our inner world, there are impressions that may be caused by these objects. That is information from our senses. This information can conjure up ideas and images. David Hume says that we cannot know for sure whether a brick really caused the image of a brick in our minds, or whether breaking glass really brought out the image and sounds of breaking glass in our heads. Just as we cannot judge with absolute certainty the cause and effect relationship between a possible brick and a possible broken glass. However, we know for sure that one impression cannot be the cause of another. The connection between impressions and the images and thoughts that have arisen in the head is beyond doubt. Impressions are causes and ideas are their consequences. In the same way, some ideas can be the cause of other ideas. At the same time, from experience, the impression of seeing a brick can evoke in us a mental image of broken glass, and conversely, hearing the crack of glass, for example, can evoke an image of a brick in our head. But we never know for sure whether there is a connection between a brick and broken glass beyond our thinking in the objective world. We see that one event always comes after another and conclude that there is a connection between them. If we want to check the true existence of this connection, then we ask, what is the connection between phenomenon A, for example, hammer blows, and phenomenon B, for example, hammering a nail? Yes, what is the connection between hitting a hammer and hammering a nail? This question may seem trivial only at first glance. We can say that, well, we simply hit the nail with a hammer, thereby hammering the hammer and the nail hard, and therefore upon contact they repel each other. But what does hard mean, and what is the connection between hardness and repulsion? It's just that bodies are made up of the smallest parts of atoms. Solid is a state of matter with a special arrangement of these very atoms, and solids repel because the nuclei of atoms are surrounded by a shell of electrons in their orbit. And when atoms approach each other, their electrons are not allowed to touch and repel. Yeah, so we've come to the point that, strictly speaking, the hammer and the nail don't actually even touch each other. But what is the connection between the presence of electrons and the fact that they repel? Well, electrons have the same charge, and like charges repel. Fine, I understand. But what is the connection between like charges and the fact that they repel? After all, if no one beat anyone up, then the answer to the last question is, what is the connection? There will be we do not know, and our ignorance is fundamental. We fundamentally cannot discover the cause. The effect relationship is an abstract concept. Not one demonstration, answer, or experiment will allow us to see how one event can cause another and possibly overcome this explanatory gap, which means it is impossible to see how event A can cause event B. We always see only the sequence of events, but never the connection between them. Yes, hammer blows hammer nails. No one will argue with this, but we don't know why. At the everyday level, we are talking about cause and effect relationships, but at a deep level, we are talking about correlation. Correlation is a relationship between two or more events, but the relationship is not cause and effect, but statistical. At a deep level, there is no reason for the investigative connection between hammer blows and hammered nails. But there is a strict correlation. In his logical philosophical treatise, one of the greatest philosophers of the 20th century, Ludwig Wittgenstein, writes, "The process of induction consists in recognizing as true the simplest rule that coincides with our experience. This process, however, has no logical justification, but only a psychological one. It is clear that there is no reason to believe that the simplest thing will actually happen. That the sun will rise tomorrow is a hypothesis, which means that we do not know whether it will set. And if you do not understand how an educated adult man in his right mind can talk about similar, then the Wittgenstein layer is defended. Who do you think? Black swans. For most of human history, the phrase black swan was an oxymoron, like hot snow, an endless dead end, or a little giant. Until the 17th century, people observed only white swans, and from this they made a logical conclusion about the non-existence of black ones. But in 1697, the Dutch explorer Willem de Vlaming in Australia saw with his own eyes that same non-existent black swan. Human thinking is poorly organized and unsystematic. We constantly see world truths in particulars, and that is why we are so often mistaken. Attempts to somehow streamline external and internal chaos. We are gradually inventing the scientific method. Today it is believed that one of the main criteria of scientificity is the principle of falsifiability, which was led by Karl Popper, and he also believed that all scientific hypotheses should be read as guesses and not as true theories, because through experience we can only judge the falsity of a certain statement, but never about its truth. 100, 1,000, 100,000 million white swans seen will not allow one to conclude that all swans are white, while only one black swan will refute this statement. Any of our theories are divided strictly into two categories: already refuted or not yet refuted. Thus, science has proven that the expression is very crude. Science offers models of reality and tests them to the point of insanity, conducting more and more accurate experiments. But checks, as you already understand, are never enough. Yes, the absence of confirmation or the falsity of a theory is not confirmation of its truth. We, like Russell's chicken, never know for sure whether we have the whole picture. Therefore, science does not prove, but only reduces uncertainty. Statistically, on January 3rd, 4159, it is highly likely that the sun will rise. Statistical hammer blows will very likely contribute to hammering nails, but the probability of neither one nor the other cannot be 100%. And what is all this based on? The entire foundation of human knowledge is based on correlation. Well, some scientists, for example, believe that in fact human knowledge is primarily built on deep explanatory theories, which are secondarily confirmed or refuted by observations. Here in the 21st century, we do not believe that the sun will rise tomorrow just because it rose yesterday. We have a general theory of relativity, which not only predicts sunrises and sunsets, but also explains why they occur. This sounds encouraging, but you will easily notice that the laws of physics have the same problem. We believe that they will continue to work in the future only based on the fact that they have worked in the past. This is the same inductive approach. You could say, relax. The laws of physics are rock. The patterns of the world around us that we know will not go away, they are stable and unchanging. There is no problem of induction. People simply pulled it out of thin air. But here we come to one of the greatest mysteries of modern physics. I can take the last 3 sheets of the script for this video and tear them into pieces. I thereby destroy the information written on them. It's hardly possible to piece together the branches and read what was written on them. And if we go further and burn them, well, that won't help get rid of what's written either, because with unlimited computing power, we could analyze the ashes, smoke, thermal radiation, and restore the lost information. The fundamental principle of both classical and quantum physics is that we cannot destroy information without a trace, because the state of any system at any moment in time is determined by its value at any other moment in time, both in the past and in the future. On this point, our entire belief is based on scientific determinism. That is, that the universe evolves in accordance with the laws of physics. And do you know what these laws tell us? That black holes exist? Remember the LEAG project, thanks to which we recently discovered gravitational waves. The guys from this project, just for fun, wrote the Poker black hole application, which will allow you to take a selfie with a mathematically correct black hole. Have fun, it's completely free. Will I destroy information if I send it into a black hole? Black holes are the simplest objects in the universe. Uncharged and non-rotating black holes are described by just one parameter: mass. 2 uncharged, non-rotating black holes with the same mass are fundamentally indistinguishable from each other. That is, by squeezing a ton of iron and a ton of turtles, you will get 2 absolutely identical black holes. Do you understand? 2 absolutely identical objects obtained from 2 sets with very different configurations of matter. One could say, yes, who cares? What happens in a black hole stays in a black hole. But then Stephen Hawking comes with his calculations and says that, in fact, black holes gradually evaporate, lose mass, and completely disappear. This phenomenon was called Hawking radiation. This radiation has nothing to do with what fell into the hole. There is a fundamental destruction of information, and this paradox is called the paradox of destruction of information in a black hole. Someone again may say that this is another fictitious problem, but wait, many scientists believe that this is the main problem of science. The same Hawking in his book, Brief Answers to Big Questions, written before his death, writes, "A significant part of scientists believes that information should not disappear, but for many years no one has yet proposed a mechanism by which it could be preserved." This paradox raises a serious problem that affects the very foundations of our understanding of science. If information really disappears in black holes, we will not be able to predict the future, since black holes are capable of emitting any set of particles. This may seem unimportant since there are no black holes anywhere near us, but it is a matter of principle that there could be black holes that emerge as punctuations from the vacuum, absorb one set of particles, emit another, and dissolve into the vacuum again. After all, if the predictability of the universe ceases to operate in black holes, then it may cease to operate in other situations. If predictability breaks down in black holes, then the problem of induction is a major ontological problem that we probably won't be able to solve. Some of our theories tell us that the universe could have come into existence out of nothing or for no reason at all. And based on the above, this view of the origin of the universe makes more sense. Effects do not have to follow the causes, and causes do not have to exist at all. If the universe appeared spontaneously from nothing, then why not spontaneously turn into nothing? So will there be tomorrow?